Okay, so we are taking notes. We're on page 139. If you are at home, pause your video till you get to 139. You'll probably want a color or two. This is not one of those assignments or lessons that is going to be really, really colorful, but it could help. At the top of page 139, you'll see that we have this big long title for the chapter, Corresponding Parts of Congruent Figures are Congruent. This is basically like a theorem or a postulate that we're going to use in some proofs to talk about how we know certain things are congruent to certain other things, bless you, in different figures. So up here at the top, in big letters, write CPCFC, and that's just the abbreviation for Corresponding Parts of Congruent Figures are Congruent. That way we don't have to write that big long phrase every time. We can just write 5 capital letters instead, CPCFC. Another thing that you will also see is CPCTC. Means exactly the same thing, but instead of F for figures, we have T for triangles, because we do a lot with triangles in geometry. And so sometimes they would specifically say corresponding parts of congruent triangles are congruent. But really, it means the same thing. A triangle is a figure. So as long as you get CPCFC, you're not going to get it wrong if the suggested answer is CPCTC, because, again, triangles are figures. So this is a bigger category than this one down here. So as we look down here further on the page, we've talked before about transformations that make congruent figures. We talked about translations and rotations and reflections and how they're isometric, or they are rigid motions, which just means that they make congruent figures. All the angles are the same, all the sides are the same, the perimeters are the same, the areas are the same. The only thing that changes is where they're located on the page and perhaps which side is facing up or down or left or right. So that's kind of what this is supposed to represent, is 2 different congruent figures. And you can just look at these figures and tell which parts are supposed to match up. Bless you. So for example, you can tell that C and F are supposed to match up. You can tell that A is supposed to be congruent to D, and you can also tell that B and E are supposed to be congruent angles, and the sides as well. You can tell which side is the shortest just by looking at it. You can tell which side is the longest and which side is in the middle, and sometimes that is all you need, but other times it gets a little harder to see that. So to make sure that we're not just eyeballing it and estimating it every time, we have what is called a congruence statement, and if you'll just write that above part C right here, congruence, E-N-C-E, statement. A congruent statement uses the corners to abbreviate a figure, and it also uses a congruent symbol. And what you do is you put the matching corners in matching order so that it's very, very easy to tell which parts go with what. So down here it says the same sequence of rigid motions that maps triangle ABC to triangle DEF maps parts of triangle ABC to parts of triangle DEF. So what they're saying is ABC and DEF map onto each other, those parts in that order. So your congruent statement, we're going to use the triangle symbol so we don't have to write the word triangle. And then we're going to put ABC is congruent to triangle DEF. If you have a congruent statement, you know 100% which parts match up. You don't have to rely on your eyes. You don't have to rely on a figure. This is all you need. To make it extra super clear, I usually stack those letters up for the first example or two. So for example, ABC on top, DEF on bottom. And when you do that, you have certain pairs of letters, and it's just whatever pairs are stacked up. So we know that corner A and corner D, they're going to be congruent. They're a pair because they're both in the first position. We know that E and B are going to be congruent angles because those corners are both in the middle. We know that C and F are going to be congruent because those corners are both the last ones listed. We also can do that with the sides. If you had like BC It would be congruent with EF because B and C are numbers 2 and 3 in your list, and so are E and F. Or even if you did AC, first and last, AC would go with DF because that's the other first and last. So you literally just use the letters to match up everything. So let's look at the examples over here and fill in these little boxes. According to our congruent statement and our little shortcut that I've drawn out for our first time over here, AB should be congruent to what other two parts? Good, DE. And we know that because A and B are the first two letters of this triangle. D and E are the first two letters of this triangle. Corner A would go with what corner on the other one? Yeah, D. They're just stacked up right there. So A must go with D if they're in the first position. What about BC? Yep, EF. And what about corner B? Because they're both in the middle. And then AC, first last, is going to be EF. And then angle C is going to go with angle, yeah. And that's all there is to it. We start with triangles because it's a small number of sides. There's not a whole bunch of pieces to make it extra confusing. So you can expand this though and deal with quadrilaterals. You could do it with pentagons. You could do it with any number of sides and any number of corners, as long as you have enough information to either make a congruent statement like this, or if you're given a congruent statement like this. And honestly, it's preferred if you have a congruent statement to pull your information from this statement rather than just looking at the shape. It's usually faster, but also sometimes your eyes might deceive you a little bit. Let's flip the page and look at another example. Okay, on 140 at the bottom, we're still doing CPCFC, corresponding parts of congruent figures are congruent. And we've got our congruent statement about triangle ABC is congruent to triangle DEF. That's where we're getting our information. You probably could do this just with looking at it, but you don't want to do it just with your eyeballs, right? If you've got this information, this is what you use. So DE is supposed to be congruent to what? Here's DE, first and second letter. Yeah, AB. So DE should be equal to AB, those two lengths. So what is AB equal? Yep, there it is. Just looked it up. So DE is equal to AB and AB is equal to 2.6 centimeters. So DE is also 2.6 centimeters. What about corner B? The measure of angle B should be equal to what other angle? E, both in the middle. So here's B, here's E. What's the measure of angle B? 65. Because that's what E is. Oops, sorry, there it is. So sometimes it's just a matter of looking it up. Sometimes you look up the number. Sometimes you can use this to tell what corners and sides and lines are matching. But as long as you've got that congruent statement, again, that is where you get your information about what matches with what. Let's look at 141, number 3, and talk about this one. It says the triangle shown in the figure are congruent. Can you conclude that JK is congruent to QR, and then explain? I'm going to go ahead and tell you that that's no. You should not conclude or assume that JK is congruent to QR. A couple of good reasons why. Anybody want to tell me what we need?
Angle measures, side measures.
Good. So side measures or angle measures, or what kind of statement? Congruent statement. Very good. So we should not assume that because we do not have any measurements. That could be sides, that could be angles, because in a triangle, remember, we've got that angle-side relationship that lets us figure that out. We do not have any measurements or a congruence statement. These look like they might be isosceles triangles, but they're not marked, so I don't know. One might be 9 centimeters exactly, and the other one might be 9.01. They would not be congruent. They'd be really, really close. I probably couldn't tell with just my eyes if they're really, really close or exactly the same. So you're not going to assume that, because if they're just really, really close and you're saying they're congruent, you're going to be wrong. Or if they are congruent and you're saying that they're not, then you would be wrong. And technically speaking, even if they are isosceles triangles, JK would go with either QR or PR, not just either one of them. We would still need some kind of information to let us know for sure what goes with what. So good job on that. We got our congruent statement on the next example. I'm going to give you a minute to do SU and the measure of angle S. This is another one of those where you just kind of look them up. If you are at home, probably a good time to pause your video and see if you get them right. Okay, so what did we get for SU? So SU is what? Sorry. 43. SU is first and last. VX is first and last. So I'm going to go find VX. There's V, there's X, 43 feet. Questions on how we did that? Okay. What about angle S? Very good. Oops, degrees. Same thing. Angle S is the first letter. Angle V is the first letter. So S must be whatever V is. V is 38. All right. So now all of this is just the what is it? What is corresponding parts of congruent figures are congruent? What does that mean? How do we kind of make sense of it? So that's what we've been doing. We've been making sense of it, showing that the matching parts are going to be exactly the same. So this next little section is applying it. How do we use it? And we use it in 2 different ways. We can use it to prove things. That's what this is for, is for proofs. And we can use it to solve for missing parts and pieces if we have expressions and stuff like that. So for the reflexive property of congruence and the symmetric property of congruence and the transitive property of congruence, these are the exact same things as the transitive, reflexive, and symmetric properties of equality that we learned back in August. Only now they just have a congruent symbol. That's literally the only difference. So as long as you get reflexive, symmetric, and transitive, whether it's the property of congruence or the property of equality is not going to be something you ever have to choose between, because remember, most of your proofs would be like you'll have 1 or 2 blanks missing, and those blanks will have some answer choices that you can use. So just to kind of recap, reflexive property refers to itself. Write that in. Refers to itself. There will only ever be one item with reflexive property, right? It might be angle C equals angle C, or angle C is congruent to angle C, but there's only one item. In this case, it could be a line, AB and AB. Notice it's not even AB and BA. It's the exact same thing both times. The symmetric property is where you could have one or you could have 2 things, but it's in reverse. So we're going to put down here reverse. AB, CD, CD, AB. They flip sides. It's the reverse of each other. You could also have something like AB and BA. One line, but the letters are written backwards. Either way, it's going to reverse. The transitive property will always have 3 items. And one of them is a link that disappears or goes away. So in this example, AB is congruent to CD. CD is congruent to EF. So AB and EF must be congruent as well. Well, what did AB and EF have in common? CD. And then over here, CD is gone. This is your link that you don't need anymore. It first links them up, and then it ends by just going away. That's going to be transitive property every time. 3 items, 2 of them are equal to a middle thing, and then that middle thing is gone. All right, so a couple of examples, but it's the same basic idea that you've been using. We're going to do solving, and then we're going to do a couple things with proofs. So we did this, but we're going to come back to it. Here's your congruent statement, and you're trying to find AB. So we should be looking at what parts of the other triangle. AB goes with DE. So here's AB, here's DE. This time we don't have just 43, 38, we have some expressions. So if AB is matching in size with DE, how can we set these expressions? Yes, ma'am, equal to each other. So 3x plus 8 equals 5x. So 3x plus 8 equals 5x, and then we can solve. We subtract 3 from both sides. I'm sorry, 3x, and then we divide by 2. X is 4, but we're not solving for x, we're solving for AB. So what do we have to do with that 4? Plug it in. So x is equal to 4. 3 times 4 plus 8 is going to be AB. So 4 times 3 is 12. 12 and 8 is 20. Now we could have listed all of those steps out in a proof if we wanted to. We could have said that if we know this, then we know that AB is congruent to DE because of corresponding parts of congruent figures are congruent. And then we would say, okay, well, if they're congruent, then the measure of AB is equal to the measure of DE because that's the definition of congruence. Congruence basically means equals. So we swapped out a congruent symbol for an equal sign. Well, if those 2 lines are equal, we can substitute their values. So by substitution, we could say 3x plus 8 equals 5x. And then that's where we pick up down here. We solve it with the subtraction property of equality, and then the division property of equality, and then with substitution. Okay. So all of these things, proofs are not something different. It's just breaking down your steps, and we're still doing those steps. We just don't necessarily always give the reason every time, but it is still the same thing. Let's look over at 142. We're actually going to do this quadrilateral on the your turn section. So quadrilateral GHJK is congruent to quadrilateral LMNP. This is your congruent statement. There's not a symbol for a quadrilateral because, would it look like a square, or would it look like a rectangle, or would it look like a kite or a parallelogram or a rhombus? It could be anything. So there's no symbol for just a regular quadrilateral, but you can put the word out there. And this still means the same exact information. It means that G and H and J and K match up respectively with L, M, N, and P. Just like that. So, again, you try numbers 6 and 7. It's the same thing we've been doing. If you're at home, it's a good time to pause and see if you can figure it out. Let's start number 6 this way. LM should have been congruent with what other line? Because LM and GH are both first and second. So LM is 6x minus 13. And GH is 4x plus 3. And then what do I do in between here? Add, subtract, multiply, divide, equal what?
Equal.
Yep. If the lines are congruent, then their expressions or measures are equal. So there we got the setup. Any questions on how we set that up? Okay, so then we solve. We'll subtract 4x from each side, and then we'll add 13 to each side. Then we divide by 2, and x is 8. Am I done? Nope. LM is what I'm trying to find. I've got x. X is not LM. So I need to plug that in. 6 times 8 minus 13 is what LM equals. So that's 48 minus 13, or 35 centimeters. Questions? Okay, so angle H. What should be congruent to angle H? Thank you. So H and M are congruent, so I'm going to set 9y plus 17 equal to 11y minus 1, because congruent basically means equals. If the angles are congruent, then their measures are equal. Subtract 9y, add 1, divide by 2, 9 equals y. Am I done? No, got to plug it in. So for angle H, 9y plus 17, measure of angle H equals 9 times 9 plus 17. So that's 81 plus 17, which is 98 degrees. Questions on those? Okay, the really nice thing about CPCFC, corresponding parts of congruent figures are congruent, is when you're solving the problems with them, the vast majority of what you'll do will be setting two things equal. Because parts are congruent, nothing's getting like, you're not cutting anything in half, you're not doubling anything. If you're looking at two figures that are congruent, their parts are perfectly equal. So you just set the two parts equal and roll. There's no mystery third number that it adds up to, none of that. Every once in a while, you'll have like a challenging critical thinking sort of question that has you solve for a missing part before you set it equal, but there will always be something that you're setting equal. Okay, so let's talk about the proofs. Mostly what we're trying to do is we're trying to see where in our proof CPCFC turns up. We're trying to see if we can identify those parts, because everything else we've really already done. So on this example, we have given that triangle ABC is congruent to triangle ABD. So here's ABD and here's ACD. So notice how that lines up. Angle A and angle A, they're congruent angles, just like that. Angle B and angle C, they're congruent angles. Angle B and angle D are congruent angles. I'm sorry, D and D. Yeah, I said B and D. So the order matters. You can't just pick any old way. You got to know which parts go with what. And we're trying to prove that D is the midpoint of BC. So what they said was the two triangles are congruent with this congruent statement, and that's what we were given. Remember, your first line should always be given, period. It will never be anything else if it's correct. Then they said BD is congruent to CD. Well, all you had to go on was this congruent statement up here. There were no markings on our diagram or anything like that. It wasn't stated. It wasn't a given. So where did they get BD equals CD? Well, they got it from the fact that BD and CD are in the same spots on those congruent statements. So that's why they put CPCFC on line 2. Now they wrote it out. We're going to abbreviate it, but it's the same thing. And so once you have BD and CD being congruent, and you got D right there in the middle, that's just the definition of midpoint. You've got two equal amounts on either side of D. That's what a midpoint is. So that's why they have definition of midpoint there. Let's look at the next one. Quadrilaterals this time. You are given that quadrilateral JKLM is congruent to quadrilateral NPQR. You're also given that angle J is congruent to angle K. And we're trying to prove that angle J is congruent to angle P. Not K like we're told, P, something different. So first line on the reasons should always be what? Every time. And we're actually given two pieces of information. Quadrilateral JKLM is congruent to quadrilateral NPQR. That's right here. Where is this one? Line what? 2. So we're going to put given again in line 2. Because we were given two pieces of information and they put it on two different lines, so we need to have given on two different lines. So now let's look and see what we've got. We've got angle K and angle P being congruent with each other. So up here, I've got J, K, L, M, N, P, Q, R. It clearly doesn't come from this. J and K are congruent doesn't give me anything else to go on because I don't have any numbers for J and K, like I'm done there. But I could get this from this congruent statement. So when I make this statement about the pieces being congruent because they're in the same spot on the congruent statement, what should I use right here? It's our new one.
CPC.
Thank you. Thank you. CPCFC. So when I get information from my congruent statement, and that's when I put CPCFC. I set two things congruent to each other because they line up in our congruent statement. That is always going to be CPCFC. Or CPCTC if you're doing triangles. And so then we finish it out. J is congruent to P. Well, let's look at where that came from. J and P are not stacked up, so it's not another CPCFC. I didn't substitute any kind of numbers or values or anything. So I've got J and K, and then K and P, and then I don't need the K's anymore. I've just got J and P. So which property, if you flip back?
The transitive property of congruent.
Very good. Transitive property. I'm just going to put transitive property. You'll never have to choose between transitive property of congruence and transitive property of equality. So as long as you get transitive, you're good. Transitive is the one where there's like this link in the middle and then the link goes away. So any questions on that? All right, let's preview your IXL assignments then for a second. I'm going to stop the screen share and then start a new one. Still recording though, for those of you here with me. Let's see. Okay, so in your Google class, first post is congruent statements. Let's take a look at that. All right, so I jump right into a big figure. Looks like there's a lot of stuff going on, and there kind of is. But look at all you're asked to do. What are the corresponding parts of the figures below? Select all that apply. So you've just got numbers. There are no missing sides. There are no missing angles. You've got everything labeled, and you just have to pick the parts that match. And that's basically what you do on the first level. So you're going to look for JM and TQ. JM is 27. TS is 27. So nope, not that one. Angle M and angle T. M is 78. T is 78. Yep, that one's good. LK is 23. QR is 23. So we got two correct answers so far. And then I've got J and T. J is 73. T is 78. So nope, just those two. And more of the same. This time though, you're using those numbers to make your congruent statement. So you got to figure out what matches in order with H and I and G. So H goes with what other angle over here? Which one's also 33?
The one that's also screwed.
Oh, oh, sorry, there's two 33s. All right, so which one is, well, I guess technically since you got 17, 17, 29, 115, 33, 33. Yeah, so we could do this either way since they're giving us the option. H is a 33 between a 17 and a 29. So you can find a 33 between a 17 and a 29. I was looking up here at M, but we'll go with M since that's what somebody said. So then after H, they go to I. I is the other 33-degree angle. Well, if I started at M, where's my other 33? It's up here, N. So M and then N, and then the last one must be L. Okay, so that's how you do those. You just kind of work them around. Let me jump a level. As long as you go in a loop. As long as you go in a loop, it doesn't necessarily matter which direction. That's a good question. So you could have technically done M, N, L just as well. Okay, same thing. This time you don't have numbers everywhere. You have 1 mark and 2 marks. But same concept applies. Sometimes you'll be giving the congruent statement. Sometimes you'll be matching up congruent parts, but that's pretty much all you do for this entire thing. Notice at some point your figures go away, but that's okay. You don't really need those figures anyway. In my opinion, it's a whole lot easier to just do it from this statement anyway. FE should go with HI. Yep, there we go, first and second. ED, that's second and third. IJ, second and third. Yeah, there we go. DE and HJ, well, that's 3, then 2, and then this starts with 1. So nope, that's not going to work. The last one is D and J. Let's see if they're in the same spot. Number 3, and they are. Okay, so that's all you do. You don't necessarily need the figure anyhow, and that's your last level. Questions on that assignment? Congruence, statements, and corresponding parts. Okay, solve problems involving corresponding parts. You're going to match some stuff up. Sometimes you set some stuff equal. Again, pretty simple. So what's the measure of angle O? Well, angle O is over here. You got a 59, you got a 31, and then you got blank. How could you figure out this missing angle? Even if you didn't know another triangle existed over on the other side, how could you find this missing angle?
Add up 180 minus 31 minus 59.
Very good. So there's 180 degrees inside every triangle. So you could just subtract and find this one, 180 minus 59 and minus 31. Or if you know that you have both triangles and you don't want to subtract, you could go, well, here's 59 and here's 59. Those clearly match, P and E. Well, so then I've got Q and O. Q is 31, G is 90. So it's clearly not Q and G. It must be Q and F, and then G and O. So if the measure of angle O is equal to the measure of angle G, it should be 90 degrees. Okay, so a little bit more thought, but not necessarily hard. Same thing here. You got your congruent statement. So BE, last letter, first letter, goes with LK. So you find LK right here. Wait a minute. B and then E, L and then K. BE. Oh yeah, sorry. L. Did they do that? I think they've got that labeled wrong. Should be 55. That should be MJ or LM. So this one is your 144. You've got a 79 over here and a 95 over here. So this one's your 79 and this one's your 95, and then the tip is 42. And so you're looking for the side in between 42 and 95. So in between 42 and 95 should be 48. I think that's supposed to be LM. That's right. What did I do? BELM. I don't know. I made it too hard. I must have misread it. But notice that's the only level. Like there's not too much else you can do with that. So any questions before I shut up and let you work? Okay. Let me end this.